Flip-flops. Flip-flops as 1-bit memory device. Flip-flops are synchronous stable storage devices capable of storing 1 bit, either 0 or 1. Synchronous means that the output state only changes at a specified point on a triggering input called the clock C. That is, the output changes are synchronized with the clock signal. Latches are level sensitive or level triggered. This means that the outputs are dependent on the voltage level applied, not on any signal transition. Flip-flops are edge triggered. That is, that they depend on the transition of a signal. This may either be low to high, rising edge, or a high to low, falling edge transition. Design issue. When using logic symbols, edge triggering is indicated by a small triangle inside the block at the clock input C. The absence or presence of a bubble outside the block is used to indicate rising and falling edge triggering, respectively. The logic symbols illustrating these concepts are shown. Types of flip-flop. Sequential circuits use flip-flops as storage elements. Flip-flop is a binary storage device that saves 1 bit of information. The outputs can come from flip-flops or combinational logic. Flip-flop inputs come from combinational logic or clock generators. Different flip-flops are different based on the number of inputs and how the inputs affect the binary state. Basic types of flip-flops operate with signal levels and are called latches. Example, SR latch. A basic flip-flop can be constructed using 2 NAND or NOR gates. It contains a feedback loop. The circuit shown is a basic NOR latch. The inputs are generally designated S and R for set and reset respectively. For the NOR latch circuit, both inputs should normally be at a logic 0 level. Changing an input to logic 1 level will force that output to logic 0. The same logic 0 will also be applied to the second input of the other NOR gate, allowing that output to rise to a logic 1 level. D flip-flop. This flip-flop only has one input in addition to the clock, called the D input. D flip-flop truth table. Note that whatever is on the D input when the trigger occurs is output at Q. From the truth table, it is clear that the input D is transferred to the output Q on application of a clock pulse. The output retains the previous value when the clock pulse is not applied. Edge triggered, and the output changes state during the positive edge or negative edge of the input clock pulse. JK flip-flop. The JK flip-flop is perhaps the most widely used type of flip-flop. Its function is identical to that of the SR flip-flop in the set, reset, and hold conditions of operation. The difference is that the JK flip-flop does not have any forbidden states. JK flip-flop truth table and JK waveform diagram. Notice that for J equals 1 and K equals 1, the output toggles. That is to say, the output at time t is complemented at time t plus 1. Let us now examine the output waveforms from the JK flip-flop given the input shown in figure. Assume that Q is high initially. Flip-flops with asynchronous inputs. Most integrated circuit flip-flops also have asynchronous inputs that affect state of the flip-flop independent of the clock. These inputs are normally labeled preset (PRE) and clear (CLR) by the manufacturers. An active level on the preset will set the flip-flop 1. Similarly, an active level on the clear will reset 0 the flip-flop. The logic symbol and the operation of a positive edge triggered JK flip-flop with active low preset and clear inputs are shown in figure respectively. Note that we assume Q is high initially. Pulse-triggered master-slave. The second class of flip-flop is the pulse-triggered or master-slave. These flip-flops are constructed from two separate flip-flops. The term pulse-triggered means that data are entered into the flip-flop on the leading edge of the clock pulse, but the output does not reflect the input state until the trailing edge of the clock pulse. This is due to the master flip-flop being rising edge triggered and the slave flip-flop being falling edge triggered as illustrated in figure. The logic symbol for the master-slave flip-flop only indicates the initial inputs to the master and the outputs from the slave as indicated by the JK master-slave flip-flop shown. T flip-flop. The T-type flip-flop is a single input device, T-trigger, two outputs, Q and Q dash, where Q dash is the inverse of Q. The operation of the T-type flip-flop is as follows. A zero input to T will make the next state the same as the present state. That is, T equals 0, present state equals 0. Therefore, next state equals 0. However, a 1 input to T will change the next state to the inverse of the present state. That is, T equals 0, present state equals 0, therefore, next state equals 1. Knowing the above, we can now formalize the operating characteristics and the state change table. The T-type flip-flop is an edge-driven device. Therefore, you should not associate 1 and 0 with levels, but instead 1 should be considered as a pulse and 0 as no pulse. Notice that if a clock signal was tied to T, the output Q would be a clock signal at approximately half the frequency of T. This property makes the T flip-flop a good candidate for applications such as frequency division.